Good evening, everybody. Let's get started. It's 5:30. So, welcome to week 3. There are noticeably fewer of you this evening. Well, this is okay because they're better seats, I guess. It might not get as hot and stuffy. Boy, are they missing out. They're probably at home still finishing off their projects. Because we've got some exciting stuff tonight. We'll open with Prime Minister's questions, and then we'll dive into it. Tonight's going to be a little different from the first two classes. I'll be doing slightly less talking, and you'll be doing some coding on your own. But we'll all do it together, and so I think that'll be good and that'll be informative. So we'll talk about code katas, what they're all about. We'll talk about the coding dojo, just give you a introduction to that. And we'll also talk about mob programming. And tonight we'll do a little bit of pair programming that we learned about last week in implementing a simple code kata all about leap years. And there's rumbling noises. Okay. I've just learned not to ask. So let's start off. Prime Minister's question. So, how's your week?
Good.
Good. Excellent. Good. How are things going on Project 1? Lots of conversations on Slack. Good. Thank you for asking questions there. Hope that's effective for you. It's quite effective for me. Question about Project 1. Yes.
I guess I feel like I submitted it, and how it ends up being graded will determine sort of how I do things in the future. I think kind of based on the number of questions that we had in Slack, like the instructions, it's like there are things that it's like in the moment they seem clear, and then it's like when you're actually implementing it, it's like, oh, actually, like this could be done a lot of different ways and be tested a lot of different ways for a grade. And so, kind of where I'm at with that.
And that's all part of the lesson, or I write lousy assignments. I can never figure out which one it is. So I'm either a great teacher or a lousy one. And I get paid the same regardless. So I'm not doing it for the money. Believe me, I'm not doing it for the money.
For 2, is there a way, are we importing someone else's appointment book class that has been made, or are we just trying to
Still using your own.
But do we still have to build something for project 2, or is there already existing interfaces that we are using?
There are, as you
just
may recall from last week. In theory, you shouldn't need to make any changes to your appointment book classes for Project 2. You're free to do so, and you might find that some of the design and implementation decisions that you made for Project 1 might not be so suitable anymore. That's fine. Nothing wrong with that. But if you're like, wow, it doesn't seem like I need to change my appointment book classes, you're absolutely correct. But in Project 2, you're going to be adding some new classes for doing the file I/O, so the text dumper and the text parser. And there's also a new main program. And actually, there was something, since we're talking about Project 2, there was a question on Slack that I didn't have a chance to get to. I had lots of people show up and ask good questions during office hours. But if we go over to, do I have my appointment book? Yeah. So for Project 2, you'll want to create a new Project 2 main class. And I'm just going to do that right now, I guess. So I'll right-click. No, come on. There we go. New Java class, call it Project 2. Oops. I'd love to add it to Git. Thank you very much. And I'll make it main by giving public static void main string args, and I'll also have a system.out.println. I'll say this is Project 2. So you make a new Project 2 class that'll probably be a lot like a Project 1 class in terms of command line parsing. There's something that I wanted to point out here. So if I then go to this, and right now I'll just do a Maven W clean package for the appointment book. Okay, and so this generates the jar file. So I say java.jar target appointment book summer 2019.jar. If I run it that way, prints missing command line arguments because this is still my project 1 main. So if I go back to project 1, right now all it's saying is missing command line arguments. So I want my executable jar to execute the main for project 2. The way I change that is I go to my pom.xml for appointment book, and here is where we configure the Maven jar plugin, and there's this main class here, and just change that to project 2. Yes. And now when I said do I need to clean it? Well, might as well. Now when I rebuild it, this will rebuild the jar, and the jar will be configured to run project 2 as the main class. So now when I run the $star again, now I get project 2. So be sure to do that in your project 2. I do recommend that you use the same code base. So you don't need to create. You could create another project that's copying a bunch of code over. If you're reasonably comfortable with Git and want to use something like a tag or a branch to sort of demarcate here's where project 1 ended, good. But if you don't want to do that, that's fine too.
So why would you create a new manifest main thing for project 2 rather than just building on project 1?
I could. I suppose I could have instead of just having project 1 and project 2, I just have project main class. I don't know. It's just the way the assignment's always been. I don't think there's any particularly good reason. I guess
different
maybe
enough that you would not just like import a lot of the code over from project 1. I guess like is all the like when you create project 2 and you say main and you change the main in the POM, what happens to everything? Because you can't use
unless you refactor it so you can use it. Maybe
Yeah.
that would be a good way of doing it. Yeah.
All right.
Good questions. Yes.
Oh, did you actually submit the create project to .sh?
There is no create.project2.sh. Like I just showed you, what I recommend is just take your project 1 code and just add the project 2 class to it, and sort of. Nope, there will be a new one for project 4.
The interfaces already exist for us to.
You don't need to import any new files, right? You don't need to make any changes to your POM except for the main class. So all of the dependencies are the same, all of the configurations are the same. And you ought to be able to use most of your unit tests and integration tests from project 1 to start with project 2. And I think that's important because you'll want to make sure that all of the command line parsing, all of the other validation for project 1 still works for project 2. And that's why the way the command line is built up over time, I'm adding options so that, in theory, the same logic can be used for command line parsing for 1, 2, and 3.
Okay. And the only thing we need to change for our pom.xml is just the main class.
Yep, just change the main class, everything else should stay the same. Yeah. Okay. What were some of your lessons learned from project 1? What are some things that surprised you? Yes.
The unit tests actually were surprisingly helpful because when I would go to refactor some of my logic, I thought it would still work, and one of my tests would fail.
Nice. Okay. Cool. So unit tests help you make changes to your code. Good. Okay. What else was surprising? Good or bad? Definitely it was a good surprise. Any bad surprises?
I thought Maven was super useful once I figured out how to use it.
Okay. Yeah, Maven. How is Maven useful to you?
Just like build a project with like one command.
One command build. Nice.
I think Maven is painfully slow.
Maven is painfully slow. Huh. I think for a project this size, actually, I think that's a common and fair criticism of Maven. I know that a lot of the Gradle people are like, "Oh, it's so much faster to build with Gradle."
And it
True.
uses a lot of resources too. Yesterday I was running a equivalent state Java repo and I was running Maven tests and it took like 15, 20 minutes.
Really? What?
Yeah.
Wait, which my repo? Oh, the big one?
Yeah.
Oh, yeah, sure. It's got like a dozen projects in it.
Still, but
Yeah.
I wouldn't expect the build time to And even in a smaller project, like maintenance pretty slow.
I think compared to make, yes, you're probably right. And yeah, invoking the compiler, well, it made it a lot faster over the years. Yes. I mean, and so then I don't think maybe it isn't optimized for speed. It's optimized for having a plugin architecture, having things be consistent. And so I think yeah, there's overhead associated with that.
And it doesn't do things like languages like Go, where it's only recompile whatever. It's different. It minimizes compilation time.
Yeah.
Don't worry about that.
And well, that's here again. This is something I think where Gradle does a better, purports to do a better job. Where they've invested a lot. So I think that's why a lot of people are going to Gradle for realsies. For me, I like maybe works well for this course because of the archetypes and things like that. But yeah, yes, good observation.
I had a question about the doc tags,
Yeah.
about the return tag.
Mm-hmm.
Whenever you have a function or a method that returns something, it automatically generate like IntelliJ will give you the tag and it will do the at return.
Yeah.
Then I read online you're not actually supposed to use it to discuss what it returns. It said like on the link that you posted for the Java doc
Mhm.
usage guidelines or whatever. It said the at like if you say like at return returns the string that is whatever. It's like bad style, and you're actually not supposed to do that. So I'm not sure.
Well, if you have something like a getter, having an at return on a getter seems silly, right? Returns the appointments. Duh, thank you.
Yeah.
But I mean, if you've got a method that computes something, that sort of does some heavy lifting, it can be valuable to have the return. Or if there's some nuance to the return, such as, it'll return null under this circumstance, or it will. Or if there's some like bounds on returns a number between 0 and 1, I think that can be useful. But you're right. If the method if the method name is so in the real world, if the method name is sort of self-describing or obvious, which is what you want to aim for, then yeah, you don't need the comment there. But at some point things get complex enough that you do need to have some documentation because either the name or the return type just doesn't make it obvious.
Okay.
Someone else have a question? Or, no? Okay. How are those cones coming? Due in a couple weeks. Oh, yeah, right? You had 2 assignments going on. There's a third one. Yeah? So let's see here. What were some of the interesting things about the cones that you learned? Those of you who are further into them, what were some of the landmines that people that are still going through should worry about, should know about?
The terminal gives you the answer except when it doesn't. And then it's sometimes unclear what the right thing to do is for a while.
There were some questions on Slack about the reflection ones using the .class notation. Did that make sense to people? Is there anything I can clarify there?
It just seems really weird because for me, it would accept certain ones in a certain format and then others in a certain format, and I'm not really sure why they didn't work with both. I don't know.
Okay. Do you remember if it was a compilation problem or if it compiled and just didn't get the answer that you expected?
It was like a couple days ago.
I know, yeah. It was a simpler time. Yeah, we were all so much younger. Okay, no, completely get it. So I think, in the course, I don't talk about reflection until like week 4 or something like that, and yep, it pops up in the cones.
So I remember the problem that I was having, which was the one, it was like where it was like the foo class, and you were trying to get it to give you like the super class $1.
Oh,
foo,
yeah.
And if you
Interclasses.
call foo.class.getClass, or just like give it foo.class, it would give you like the java.lang.object. But if you made a foo object and then called foo.getClass on that, it would give you the right output.
Right. Yeah. So interclasses and nested classes again we go into more detail on those in the reflection lecture. So if you sort of like hobbled your way through that, or hey, I got it to work, and okay, I'll move on. that's okay. You can come back to it and make more sense, or maybe you spent the time to do a little bit of research and figure out what it means. You got it working. Yeah, good deal. Okay. Yeah.
I have a question going back to project one.
Yeah.
So like when I was doing project one, I think I was kind of basing it off of like the videos from project 0 and how you made the exceptions in there.
Oh yeah.
And then so I think they were, I can't remember if they were the runtime exceptions or.
Yeah.
But you didn't do the try catch statements.
Right.
And then I went back and looked at the like the screencast for previous years, and you had mentioned in those that we should use the kind of exceptions that require the try catch statements for the purposes of this class, even though maybe they had fallen out of favor.
Oh, that sounds like something I would say.
And
Okay.
then in project one, so the directions were to have user-friendly
Error
messages for errors.
Yeah.
And so I was using, I guess, the runtime exceptions for those instead of the
Mhm.
try catch. Is that, I don't know, does it matter? Or?
Well, I think as I said last week when we were talking about project 2 and what graceful exiting means, that you shouldn't see a stack trace.
Uh-huh.
So just printing out the the message of the exception is good. If it kind of bubbles over and it's like the whole stack trace and everything, you might lose a little points for that. So if you don't catch it and then issue a nice error message there, if you don't catch it and the exception bubbles over into the command line, then that's not pretty, right? I mean, you don't want to see like all the
We didn't really understand
source code and stuff like that.
Okay, so what's the
Yeah.
definition of a pretty error message then?
Well, something that the user can understand that doesn't look like code. So like a stack trace with stack trace, not so good. Just the exception message though probably is pretty good. If you said, oh look, invalidate format, something like that.
Okay.
Yeah.
I think that's what I did.
We'll find out this weekend, won't we? Yeah.
And I guess my other question was, again, kind of looking at like the videos. So in the videos for like the testing for the number of arguments, like for the IT testing, I think you were like writing to standard, I think it was a standard error, and then exiting one versus like with the errors in the unit testing, you were just kind of doing those exception messages.
Yes.
So like, why is one for one situation, the other for the other?
Well, the unit tests and sort of the implementation classes, so like appointment book, those are just classes. Those are APIs. The user for those is the code that calls it. And so then you want to communicate with the user using the user's communication tools, which are return values and exceptions and all that, the language stuff, right? Now, the main method that its user is the person. User is the terminal. And so you communicate with that client, that user, using things like exit codes and standard out and standard error.
Okay.
And so then, but sort of the lesson here, and this is really going to be driven home in Project 4, when you take all of these classes and put them inside a web server, you'll realize that, wait a second, standard output and standard error aren't a thing anymore. The exit, you don't want the VM to exit because that means your web server crashes, right? So you communicate with the user in a different way because it's a different client. It's a web client. It's not a command line program. So it might be more meaningful in Project 4 than it is in Project 1. Nice.
Did you write the main method result class?
Yes. Yep. It's all my fault.
Because I was looking at other ways to, because I was trying to do like something else with another project not related to this class. And I was like, oh, like this is like really nice for things that are printing to like standard out. Because otherwise, like I found like some stuff where it's like you are doing input streams with like the get byte arrays.
Which is what it does underneath the covers.
Okay.
Yeah.
Okay.
But it's the system.exit, which is like the magnifique. Yeah. So awful.
So when you say that like something like that isn't like just like naturally part of like the Java like libraries because like you said like maybe most applications are sort of doing stuff that don't.
Yeah, I mean, yes, and really, in terms of what you should be testing, it ought to be. So then the whole idea of integration testing is that it sort of hits the outside of the system. Well, you want to unit test everything as much as you can inside the system, as using unit tests because they're faster to run. It requires less setup. There's fewer dependencies, so fewer race conditions and all sort of weirdness and stuff like that. So that's all well and good there. And so then you want to have sort of as few integration tests as necessary to test all the stuff on the outside of the program.
So for project one, we have more integration tests than any tests in our other test classes.
And that's
backwards. It's kind of upside down.
well. It may be an indication that the main method is doing too much. So then, you can ask yourself, should maybe I refactor some of that logic in the main method out into either another method that's testable as a unit test, or maybe a class that's testable as a unit test, so that I can, test all the command line parsing and not have to deal with all the standard out, standard error manipulation. Yeah. Okay. Any questions on project 2? I realize probably a lot of you have just now submitted your project 1 or just catching your breath. But anything that you want to talk about now, since you got me in real time? No? Okay. Oh yeah, question, yeah?
So after you update your prompt, should you have to re-import into IntelliJ?
It might make you. So IntelliJ, is this? Oh, look! It looks like you've changed your POM. Clippy comes up and says, "You want to re-import?" You probably should. So nothing ought to change really. It's not like you add any dependencies. But without analyzing it, IntelliJ doesn't know that. So it doesn't know that. Oh, all you've changed is like the main class. It's just like, oh, hey, you probably want to re-import, and just tell it to re-import, and it'll be fine. Okay. Project 2, is that really next week? Is the 17th? It is, isn't it? Summer's flying by. Yeah.
We don't, for project 2, we don't need to print out on the dash print, we don't need to print out all the appointments that were parsed out.
Nope. Just the most recently added one. Right. So the semantics from project 1 do not change. And so therefore all of your test cases, all your test cases from project 1 ought to apply to project 2. Yep, so all you're doing is just adding a text file parameter and handling it accordingly. Okay. So, any questions, anything else before we start diving into it? Yeah.
I've got one out of
Yeah.
convenience.
Sure.
When you commit through IntelliJ, it will tell you like X many errors found. Is there a way to do that besides, I'm sure there is, besides committing, just to have it check for you?
Yeah, I think so. There's a way to analyze, maybe inspect code, whole project. Yeah,
Just the first thing or the most obvious place to look. Cool.
No, I don't know. It wasn't that obvious.
Okay, I see.
Well, it's funny, who looks at menus these days, right? I don't know.
Yeah,
Right? You can look at cyclic dependencies and backwards dependencies, and I don't even know what that is. Backwards dependencies. Oh, here's a neat one. Analyze stack trace. So let's say you've got a stack trace. I wonder how I have something that can do that. If you have a stack trace that gets printed into a log file or printed to the terminal or whatever, you can copy onto your clipboard and then do analyze stack trace. You can just paste it in here, and it'll then you click OK or whatever, and then it'll give you a stack trace that you can click on the line numbers and everything, go directly to the source code. That's nice. That's one of my favorite things in IntelliJ. That comes in handy a lot.
It also works for thread dumps.
Sure, yeah, thread dumps too. Yeah, if you do a kill-quit for the VM, yeah, nice.
For the project 2 IT file, is that as simple as just making a new class for project IT, or is there anything that you can do to link it to
Nope. No, for the integration test. So anything that ends in .it, it'll run. So you might even want to rename project 1.it to project 2.it, or maybe have project 2 subclass project 1 if they're all. I don't know. I've never done the assignment before, so I don't know what it's like. Yeah. Okay. Good deal. Okay. Nice. Okay. Thanks for all those good questions. Hope they helped. Okay. Week 3. Okay. So in weeks 1 and 2, I walked you through the student project, and we saw a bit about the Java language. We saw, of course, classes and methods. We saw enums. We saw command line parsing. We also talked about TDD, test-driven development, and unit testing, and integration testing, red, green, refactor, all that good stuff. And so I did a lot of the coding, and you got to see that. Tonight I'll do some coding with you and in front of you. But now we're going to add something new to the course, which is that you get to code. And you'll get to experience pair programming. Maybe next week we can do some mob programming and stuff. And the way we're going to do that is through what are called code katas. So I'm not going to read all of this stuff, I guess. But so a kata is in martial arts a little practice, a little exercise. It sort of teaches you one thing, or is a way to get started with something. And so then there's this. There's a number of katas out there on the internet, and there's a we'll talk about coding dojos and stuff. But one of the things that, like, hey, a bunch of people want to learn a new programming language will do is, much like the koans, will get together and collectively work on building these katas, work on doing this exercise to teach them more about how to program in that environment. And sometimes it's a couple people getting together, but another way of doing it is using something called a coding dojo. And so the dojo for martial arts is the location in which the learning happens. And so I'll play a little video here. Make sure that the volume's turned up, which explains what a coding dojo is.
So what is a coding dojo? Well, first off, the most important part is really the setting. So if you imagine the setting to, of course, have a single computer, it's attached to some kind of projector, and of course that projector is projecting up on the wall here. And then the other important part is to have a secondary space, usually a whiteboard or a flip chart, where the problem and ideas can be written up there. Along those lines, of course, you've got two pair programmers or spars who are working together, a pilot and a co-pilot, and then you have the dojo participants who are sitting around, usually no more than, I'd say, 12 to 15 people. Okay, so that's the setting. Now let's go on to the people, the roles, and it's important to note that all of these roles have to actually have someone in place at all times and acting as responsible for the job of that role. So role number 1 is the sensei. As you can see here, there's no sensei listed, and that's because usually the sensei is somewhere off in the distance in the background, watching and guiding the dojo, not giving instructions or solutions, but rather pathways to the solution. Remember, there is no spoon. Okay, number 2, pair programmers. These two people are the spars. One of them is the pilot, so one of them is typing, and it's their job to write down the syntax and start to throw out ideas in a way to be on the offensive, to be the attacker, and to get the ideas up on the board so that the rest of the people can overlook at it and provide other solutions. The other person, the co-pilot, the fellow pair programmer or spar, their job is to look over the other code that's being written by the first spar and to kind of be on the defensive, to try to help and suggest ideas and to kind of quietly whisper in the ear and help the first person. It's very much the idea that these two people are working together. They're not fighting. They're training one another to be able to do the best job in the same way that a kata would be performed in karate. Finally, other than your two pair programmers in the middle, are kind of the advisors. Now, it's really important to notice that all of these people that are around the room, they're all participating at the same time. Oftentimes, they'll hop up and they'll write on the problem board themselves. They'll shout out answers if they see something done differently by the primary pilot programmer. And then the other important thing to notice here is that everyone has to take an opportunity, a chance to be a pilot and a co-pilot. So you'll very much have people switch out and to take their opportunities. Usually about 15 to 20 minutes, someone will sit in the pilot and co-pilot seat and then switch out. So usually you'll take your first go as the pilot because you'll need to learn how to type the syntax. And then once you're kind of getting the idea of how to type the syntax of the code, you'll have the second co-pilot who can then swap over and help advise the new person coming in. So everyone in the entire programming dojo must participate. Which brings us to the rules, actually. So let's go on to the rules of the coding. So now let's go to the rules of the dojo. So one of the most important parts is, number one, the sensei asks questions, does not give answers. And so the real point about the sensei, who's obviously kind of somewhere in the background to this activity, is just providing guidance. There is no spoon. They're just teaching you how to move forward. Often the problem that they give, or the challenge they give, is given beforehand, usually a week in advance by email, so people have time to think about it. All right, rule number 2. All must participate in code being written. And what it means by that is that all of these participants around the edge who need to take their turn in the middle at some point, all of these people need to be watching the primary coding board. So what's going on with the two sparring partners and what they're writing? They need to be looking up here and participating, and ideally helping contribute by suggesting solutions. They should not have their own computers out. Not really. They should be, unless they're trying to look up stuff or something else. I mean, there's no strict rules, but ideally they're not coding by themselves. They're trying to team code and help this person learn as much as the rest of them will have help themselves when they code. Finally, rule number 3. Everyone must participate in sparring, which means that everyone must take their turn as pilot and co-pilot in both typing and also helping teach how to type. So this person, this person, this person, this person, this person, so forth and so on. Every single person should switch out at some point, come and take their turn to type, and then swap out and take their turn on helping to advise and all the rest of it and give solutions. So that, in essence, is the Coding Dojo. Cheers.
2010, gosh. It's old, but I was that old. So, now, in case any of you are worried, we're not going to do a Coding Dojo tonight. We might try it next week, but I hope some of the things that you took away from that is that there's a way to learn when everybody's learning together. And when, there are a couple people that are in the hot seat that has everybody's attention. But this is a very effective way to educate a bunch of people all in the same thing. We're going to be doing some stuff that's similar to that tonight. Tonight we're going to be doing some pair programming on a coding kata. And we'll get to that in a moment. So that's the Coding Dojo. There's another video that I wanted to show you all about mob programming. So pair programming is two people at the same computer, talking back and forth, but it's just the two of them focused. Mobbing is much like the Coding Dojo. It's a way of scaling up pair programming. Or actually, it's more like group programming, where again you have everybody, the entire team, but not necessarily just the programmers, participating in coding. So here we have the team. I guess what we don't see, you can see it there. You can see the projector. This is where this is the code there, and Woody over here is at the keyboard, and he's sort of setting the stage for the day. So, after talking for a few minutes, figuring out what they're going to do that day, this is where people start doing it. So, this is a variation on pair programming. There's a driver, there's someone at the keyboard, but there are multiple navigators. There are multiple people that are contributing to the discussion. The product owner isn't someone who necessarily writes code, but they're the person who wants the code written. And so then they're able, in real time with the code, to be able to provide feedback, to be able to provide suggestions on how things are going. Notice that this is just the way they work. People will get up, take a break, maybe go to a meeting, come back, get a snack, things like that. He's there working at his desk. Yeah, he has to file an expense report. This is just the way this team works. And what they found was they were able to take the same 5-6 people that usually work together as a loosely coupled team, where people go off and do their own things and integrate it. And by having essentially zero feedback, in their work. They got No, they said 10 times productivity. Whatever, they got a lot more done because everybody was always on the same page. There was no discussions about, oh, hey, I wouldn't spend 2 hours doing that. Oh, that wasn't the right thing. Or it's like, oh, I wrote that, I reviewed that code that you spent 6 hours writing. Oh, it looks like we disagreed on what the requirements were. None of that stuff happens because everybody's going, everybody's working together in real time. And so then, I think one of the things they point out is that, this isn't a team of individuals, it is a team, right? So it's more like soccer and less like baseball, right? So it's everybody's, running together on the team. Sure, only one person's got the ball all the time, but, they're all focused, they're all playing the same game, and they're all engaged. Apparently no food comas. Okay, that's good to know. Must be on a low-carb diet or something. Does anything else interesting happen this afternoon? I don't know. But yeah, and here again, I think the big, the brilliant people. Here again, everybody sees all the code being written. Everybody has an opportunity to contribute to it. And this makes the team so much more resilient, right? So instead of having a situation where someone gets sick and all of a sudden no one can make any progress because that person has all the information, instead, someone gets sick and that one individual, loses a day of continuity, but the rest of the team can keep functioning. So anyway, that's what mob programming is all about. And is that Gandalf? Oh, that's okay, Rabbi Friedman, whatever. Yeah.
You said that in the workplace, pair programming is not very common.
Mob programming, even less common.
Right.
Because here again, it takes a lot of vulnerability. Now, I mean, mob programming was like really bleeding edge a couple of years ago. It was like popular, it was really cool in counterculture, and so some people were doing it. There are other, but it hasn't really taken off. You hear some people who like it a lot. Again, I think in some organizations it'll be like management pushback, but I think in a lot of other organizations it'll be individual pushback, right? I mean, how are all of you? How are you feeling about having to do something like coding dojo where you're up in front of everybody, right? That's not comfortable. That's not what we were taught to do. That's not what we're used to doing. And actually, especially in academics, right? We don't have a culture here of getting up in front of people and being quizzed. That's really not the way the American educational system works. And so it's the same way, we aren't used to coding out in public. But that's changing, right? I mean, and GitHub has changed that a lot, and open source has changed that a lot. So where 20 years ago. Yes, there was this thing called open source, but it always seemed like it was not the norm. It was like, oh, that's my hobby stuff I do in my my free time. Well, now it's kind of the opposite, where lots and lots of people put their code out there, and that takes some amount of vulnerability. And we've all looked at somebody else's code on the internet. It's like, that's awful, right? But still, it's it's what people need to do. So I think it's just an evolution of how we work in our profession, and there's lots of evidence. I've heard some of those people in that video talk about their experiences, and for them it works really well. For their organizations it works really well, but they're still a very small minority. But I want to give you guys the opportunity to experience some of that. So again, not tonight. We won't do mob programming. We'll save that for next time or the time after. But I wanted to have you watch the video now so you sort of know what to expect. Meaning I expect to see a few if you're here next time, but that's okay. We will we'll have an awesome mob regardless. So anyway, coding Dojo and mob programming. Any other questions about that? No? Okay. So let's get to what we're going to focus on tonight. The leap year's kata. So the thing that I like about these coding katas is that they tie in really well with test-driven development, meaning that there is a pretty simple problem, and so then it's relatively straightforward to understand the problem and brainstorm some test cases. That's where we're going to start tonight. So I hope you all saw in the link the link to this kata. So here in week 3, I'm not going to read this entire page to you, but I hope you all know what a leap year is. If you don't, there's some stuff there. But the whole idea is you're going to write a simple program that takes a year and determines whether or not it is a leap year. And so there's some simple logic. to determine if a year is a leap year. And that's ultimately where you're going to need to implement. So I think what I'm going to do first, though, is show you. So you're going to write this using test-driven development. So how about we do this first? Let's do a 1, 2, 4 all exercise. So the first thing, what we're going to do is we're going to take 5 minutes and silently think on your own, enumerate some test cases for this kata. Read over the kata and enumerate some test cases in your head. Then what we'll do is find a partner and talk about your test cases. Compare notes. Do that for 5 minutes. And then we'll form groups of 4. So find another pair, compare notes or figure out all your test cases, and then we'll talk as a group to identify some test cases for this kata. So first off, we'll put 5 minutes and read over the kata and come up with some test cases. I think some of you saw I created a new channel in Slack. I'm going to put some links and stuff as way I can share it with everybody. So I encourage you to subscribe to the or to join the Coding in Class channel. Okay. Okay. How about you find a partner and talk about some of your test cases? Compare notes. Okay. Okay. Let's get back to it. All right. So we did what's called a 1, 2, 4 all exercise. So we all thought about the test cases on our own individually. Some people taking some notes, some people getting some ideas down. We talked in a pair. They talked among 4 people, and so now let's do a report out. So what are some of the test cases that we identified for our kata?
Has to be 4 digits. 4-digit number.
Ah. Okay, so the year must be 4 digits.
And also must be positive.
Oh, yes, a positive 4-digit.
Criteria doesn't say that.
Wait, does it have to be 4 digits?
Years are not
What about the
negative.
Well, it starts at
so-
1583.
It doesn't say that either.
Yeah, it does.
Yeah, it
Is this in the
does.
context of our project one, or are we talking in the
No,
context
because there were
of
leap years
before 1582?
Yeah, for the kata.
Technically, no.
Okay.
Well, there were every
When was the
4
first
years
leap
with
year?
no other rules leap years. Before that, they were foolish leap years. They didn't have to do it.
Ah,
Back in the day before 1582. Just do it.
that has to be pre or that. 1582.
It just says that prior to 1582, there were years when what was a leap.
Right.
In the Julian calendar.
Right. Yes.
Are we only testing this
Nice.
Landline argument, you need to specify which calendar you're using.
Ah, yeah, right. Dash Caesar Julian. Yes. Okay.
Send it back to process.
So, but it is important to determine whether or not we accept dates, years that have already happened, or if this is only for future dates.
Okay, so when the year is before 1582, sorry, what do we expect?
The divisible by 4. So,
That all years divisible by 4, so by 4 are leap years. Okay.
So we can accept like the year 4.
So that's the distinction, is that before 1582 is just divisible by 4. After 1582, there's 4 criteria that all have to pass.
Is
Yeah.
the Gregorian calendar retroactive?
That's the reason we skip like basically a whole month.
Yeah. Yeah.
All of this is not in the acceptance criterion of our problem, so therefore it is irrelevant to the tests that we need.
That is true.
It does not need,
I mean-
it could be negative 400, and that will still be in all of the acceptance criteria.
I mean, the user story does say that so they can plan for an extra day, which implies that only future dates should be accepted.
Yeah, you ain't gonna need it.
You ain't gonna.
Unless they're time traveling.
It's true.
Totally.
It's kind of arrogant to just presume they're not going to be time traveling.
I mean, no it's not, 'cause it's impossible.
Okay. What are some other test cases that people came up with?
2000 is later.
Yeah.
That's what I was
Are you
thinking.
gonna start?
I mean, your code throws an error if it's given the wrong input format.
Okay. If the code is given and a non-valid year, like a string that doesn't represent a number.
Yeah,
Yeah.
or it's in the wrong format, or it's like, apostrophe 89.
MTV Spring Break. 1889? I don't know. Everybody's in bloomers and stuff. Those stripy swimsuits. Anyway, doesn't represent a valid integer, positive integer. Integer. Okay.
What about if year mod 4 does not equal 0, it assert that it's not a leap year?
Ah, so any year not divisible by 4 is not a leap year. Nice.
Would it be excessive to, like, if you're taking, because you get the input as a string, and if you're converting it either to like a date type, a date object, or a long or an int for like doing math on, would it be excessive to test that conversion succeeds?
Well, I mean, is that
Or would it just be like,
essentially what you're saying here? Is that if you're given a string, I mean,
well, it's one thing to check the format, and then it's another thing to check like if you're trying to instantiate it as a different object. Do you want to check that succeeds, or is it enough to just, if the later tests that rely on it being a number pass?
well, I mean, I think at some point you need to trust some code.
Yeah.
So yeah, I mean, do you really need to test, integer.parseInt? Probably not, right? So you trust that. You trust that, that addition works on the chip, right? Or it depends. At some point you need to bound your tests. It's probably the test of your logic, not necessarily on the underlying, things on which you depend. That's a good exploration.
If it's not a leap year, you receive a message saying it's not a leap year.
Mm-hmm.
And vice versa for it succeeds.
What about odd years are not leap years?
Well, I mean, is that already covered by
I suppose so.
that?
Yeah, I wonder how you decide overlapping tests. Like what's the process there?
I don't know if I have a good hard and fast rule.
Yeah, I guess if it's not divisible by 4, then it's
I guess if you write tests and it passes without change, if you're doing TDD and you write a test and it passes without changing any code, if you never get to the red state, probably not a terribly interesting test. Either that or maybe you've implemented too much. Yeah. I don't know. And sorry, I guess one of the things is that the reason I'm starting with the tests is this is an opportunity for you to experiment with test-driven development. I mean, if you haven't done it yet, this is sort of part of this exercise. It's not just to get the kata done, but it's to get the kata done doing pair programming with test-driven development. Sorry, you guys saying?
Isn't any year not divisible by 4? Isn't that a bound test case? That's not how are we testing? Are we testing everything not divisible by 4?
Right. Yeah.
So I mean, technically, we could just write 2 test cases if that were the case, and if they failed. But I think we need do we need specific years that we're testing for here?
You just say year mod 4 equals 0 or not.
Well, because we need an initial set to test there, right? We can't just
Right,
4.
that's true.
Yeah. Okay. Wow. So that's good. So what are the representative dates that we should test with?
So would we could just create a for loop that generates a bunch of numbers not divisible by 4, and then every number from
Yeah. And if the same code gets executed over and over again, good.
Just do it once and store it somewhere. Use the acceptance criteria.
So I have a comment. I kind of agreed with him more because I feel like any year not divisible by 4 is not a leap year. I feel like that's not a test. That's the logic that's in the program. And I feel like the test should just be maybe I'm wrong. It should just be the numbers that they give in the examples. It should just be 2000 equals true, 1700 equals false, 2008 is true, 2017 is false.
So leap year
And
is
also
leap year as well. Leap year is leap year, and non-leap year is not leap year.
But with numbers.
Right.
Would you say, so that question about whether or not you try to test every year, that's the difference between code coverage and test coverage?
Yeah, maybe.
I was just reading about it today, and I still have questions.
Yeah, code coverage versus test coverage. Right, and maybe it's more of a black box versus white box testing. So, black box testing says, aha, we want maximum code coverage, or we go and look at the implementation to see if we've gotten all of the edge cases. Whereas the white box testing says, hey, we're going to understand a representative, I like the word to use, representative test sample of the domain that we're working in, and that's what we're going to go with.
So it's enough to just kind of have a sampling of numbers that you know should fail.
I think in something like this, yes. I mean, so if you're, let's say you're testing, division or something, you don't divide every number by every other number. What you do is you go and look for the, the edge case. It's like, oh, do I have like a negative divided by a negative correctly, and does it result in a positive? Or what happens when I divide by 0? There's an edge case, but you don't divide by every number.
Then you wouldn't have to go as far as like downloading a text file of the next 1,000 leap years and making sure that they all pass.
Probably not. But this is why it's up to you. Cool. Okay. So then, now that you've got an idea of how things are tested, let's write some code. And to get us started, I'll show you how you can create a simple project. So I have my checkout of my summer 2019 repository. I will go get the upstream changes, see if there's anything interesting here. Oh, interesting. Oh yeah, I have some local changes that I need to commit. So let's see here, it didn't go through. I need to, added code for demonstration code for project 2. Commit that. Oops. Now I should be able to pull, it'll merge it in. Nice, okay, a couple of changes there. Okay, so a little while ago, I created a script called Create Simple Project. And so then if you guys do the upstream merge, you'll get this Create Simple Project script. And this takes 2 arguments, the name of a project and a student ID. So I'll call it like leap year, and then student ID, so mine's Whitlock. And what this does is it creates a project which is, it uses the student archetype, which is like the simplest project we have, right? It's got one main class, it's got a unit test, it's also got an integration test if you want that, but it's got all the POM and everything like that. And so now I have a leap year file here. And so I'm going to add that to Git. Added a leap year, a project for the leap year kata. And I'm going to, actually let's make sure that it builds, so I'll use the Maven wrapper, chmod plus x, Maven wrapper, clean verify. So while this is going, so those of you playing along at home, am I going too fast?
What was that thing you wrote again? Like create simple project and then.
Yep, the first thing is the name of the project, like leap year, and then your user ID.
Did you just Maven verified it?
Yep, so I changed in the directory, so I created a new Maven directory. Okay, good, it all works there.
Cool. So then you CD in the POM and then there you can.
Yep, and so now we'll just open up that project. Let's open up that project. So, no, PSU get leap year, pom.xml, open as project, new window. Leap year, there it is. Cool, okay, so then first thing that you'll want to do is go through and rename all of the files to like leap year or something, I don't know, whatever you want to call it. And by the way you rename things is that you use the refactor rename, it's Shift F6 on the Mac, and call it leap year. And it's smart enough to say, oh, listen, you're renaming student to leap year. Do you want to rename these other classes like the IT and the student test? And you say, yes, yes, I do. And let's see here. And I think also, will it change the Maven POM? Oops.
Oh, but it didn't change.
It did change that. Yeah. Hmm?
Class. Still class student that extends to me.
Oh, did you rename student? The student class, suppose like the student constructor or something?
When you renamed it, did you just right click on it?
Yeah, right click, probably rename or refactor and then rename.
Okay, cool. I think I tried rename file and it didn't.
Oh yeah, rename file probably isn't. Yeah, you want to rename the class, and that way it's smart enough to look for usages of that class and things like that. Sure, I will enable auto import. Okay, so I'll go make sure that it still compiles there and does the right thing. Okay, now it's got some leap years, so then I will commit those to version control. Delete that. Okay. And so now I'm probably going to go and delete a whole bunch of stuff because I don't need all this student stuff here. Actually, all this stuff, I'm just going to leave the main because I don't know exactly what this class is going to look like. I might even, oh, I don't need to extend human anymore. And I'll just go find the tests and stuff and delete those. So you're free to do this in your own code. If you don't want to do it in your own code, then you can just make a clone of my repository that'll have my stuff in it, and you can go from there if you really want. But anyway, do these things still work? This might still work. Yay. Okay, so let me just make sure that it still works okay. So anyway, so what you're doing here is sort of what we saw, what you do with your project one, what you saw me do with my student. You're just creating a new new project. Oh yeah, no tests to run. Yeah, I gotta remember to do that. Leave your test. Test void first test. Set something.
I don't know, is there, every time I do the Maven from verify, it asks me if I want to import the Maven projects. There's Maven projects that need to be imported.
In IntelliJ?
Yeah, if I tell it to do that, it like breaks everything.
You're running, where are you running Maven clean from?
This time I just did it from within the leap year file.
So you're running Maven from IntelliJ, through IntelliJ?
No, from the terminal file.
Oh, and that messes up your IntelliJ?
Yeah.
Oh, I'm sure.
It asked me if I want to import Maven projects. It's like there are Maven projects that need to be imported. And when I did it with the appointment book stuff, it would, when I would try to run my project IT, it would say that it couldn't find like the main class.
Oh, that's interesting.
It would just like lose track of things. But if you recompile, then it figures it out.
Yeah, so somehow it must be losing track of the class files. I don't know off the top
But
of
it's
my
only
head.
if I let it import the changes. If I don't,
Yeah, so don't
it's
import the
there.
changes, I guess, because
Yeah.
you're not really changing it anyway. Huh. Interesting. Okay. Huh. Okay. So, So actually, let's. Okay. So I'll put a couple instructions here also to get started. Break off into pairs and start doing the kata. Start implementing. I encourage you to do a test-driven. We'll do that for a little while, and then what I'll do is I'll post a Google Hangout that pairs can join, and you can share your code with the rest of the class.
We're not extending.
Nah, we're not extending human anymore.
Just get rid of that.
Yeah, just delete that.
Yeah.
Right now, so we're supposed to pull
Yeah, and then you open the con file and it's you go file to project resources, navigate to the correct directory with your pom.xml.
Okay. Let me pause the recording here real quick.